Hello, welcome to today's class on understanding geography with diagrams. Today, basically, while explaining you the thornthwaite, I would be using my notes, self notes, because that would be more easy for you to understand. Because at the end of the day, you have to read it from the notes itself. Now, let's move on. See, Now, one of the now the applied category of the climatic classification primarily attributed to the American scholar. Remember, Köppen was a German Russian scholar. This this is Thornwood was basically an American scholar who presented the first classification scheme in 1931. It was in the 1931 itself when he presented his first classification scheme, almost parallel to the Köppen's classification scheme utilizing relative temperature and precipitation. Remember that what Köppen had done, one of the biggest demerits of Köppen was that he used absolute temperature and precipitation. Next, in his original scheme, he demarcated five humidity provinces. What are humidity provinces? We'll just read it now. But each provinces was denoted with the capital alphabetical symbol with well-defined type of the vegetation. So basically, he said that the provinces were defined as per the humidity. Means, see what Köppen did was he divided the region as per the kind of a climate, equatorial, tropical, this, that, and all. But he says that he took into account the humidity prevailing in that climate, and it is based on the humidity as well as your vegetation that he determined the climates, and he also took into account the pressure into the account. Next, this recognized, see, in 1931 and 1936 and 1938, Thornwood attempted an improvement to his 1931 scheme. However, his approach never generated that kind of support and utilization that Köppen's classification attracted. Why? Köppen was very simple in his approach, whereas Thornwood's approach is very complicated. You'll just know it right now. Now, Thornwood thereby attempted one of the most sophisticated applied climatological classification scheme in 1948. In this, he introduced the concept of he introduced concept of potential evapotranspiration, or he called it P by E. He defined it to be the amount of moisture that gets evaporated or transpirated. Transpiration, remember, it's nothing but the that the evaporation that takes place from the plants after the attainment of the moisture. He emphasized that it is the potential evapotranspiration that avails the analysis of actual amount of moisture left out in the air or soil to regulate the climate and related activity. It is due to the lack of availability of the data for the potential evapotranspiration, he demarcated four different indices with different sets of alphabetical symbol, combining which he attempted to calculate the potential evapotranspiration. See, basically understand this. What is potential evapotranspiration? It says that after a region which has any region which has received rainfall, now, after rainfall, what happens is that the water gets evaporated. The amount of water that is prevalent in that region, plus the amount of water that is prevalent along with the flora of that region, that is through transpiration, will determine the climate. Because the water that will gain from there will determine the kind of a climate, will determine the type of the humidity in that region. But however, such data was not available. That is how after rain how much water is left in the atmosphere, no, how much water gets evaporated, that is not available. What we had with us was humidity, but not that. So he developed this humidity provinces so as to calculate it. The first was that first table was of the humidity provinces. He basically what he did, what he formed different four different indexes. The first was humidity provinces. Humidity provinces nothing, calculated based on the index of moisture humidity okay, it is calculated based on the index of moisture. Humidity provinces were simply enlarged into the list of original classification scheme. Nine different humidity provinces were denoted with the capital alphabetical symbols. Look at this. We have the A, we have the B, which is divided into four category. A is called as the par moist, B is called as the moist, C and D, it is moist subtropical, dry subtropical, D is the semi-arid, and E is the arid. Earlier, remember that we had taken B as arid where? In the Köppens. But B over here is the moist. I hope you get that. Next. The seasonal variation in the humidity provinces are denoted with the small alphabetical symbol categorized into aridity index and humidity index. See, basically what it is saying that this aridity index that he developed will be applied to where? To humid region. For example, if we applied the aridity index to your selvas. Where is the selvas? Selvas is nothing where in the Amazon. R for no deficit, S for minor summer deficit, W for minor winter deficit, S2 for major summer deficit, and W2 for minor winter deficit. Please analyze this and you can get it very easily. Just analyze it. Next, humidity index will be applied to where? To arid climate, just like your desert. D is for no surplus, S is for minimum winter surplus, W is for minimum summer surplus, S2 is for major winter surplus, W2 is your major summer surplus. Next, the third indices would be used to calculate your evapotranspiration. Next, it talks about the thermal efficiency index. What is it? The thermal efficiency index is based on the thermal efficiency of the region. Wait just a second, just look at it. See, this is your thermal efficiency index, is your third index. This thermal efficiency index would be used for calculation of your evapotranspiration. The thermal efficiency index based on the thermal efficiency of a region but demarcated by the scholar in accordance. He distinguished 9 thermal efficiency region. Similarly, we had the basically we had over here what? 9 moisture provinces, sorry, humidity indices. We have over here there's that 9 different thermal efficiency region denoted by the capital alphabetical symbol. Let's go and see. See, this is in the humidity index. We use this A, B4, B3, B2, B1 like we had seen in the above. Next, it says that this is how we classify. That is A dash, that is your megatherm. Next, B1, B2, B3, B4, that is mesotherm. C1, C2, microtherm. D, E dash, D dash is for tundra and frosty. This is for your third indices. And next we have the fourth indices, that is your seasonal variation in the thermal efficiency index. This is your fourth index, and this is basically the table for your fourth index, which calculates the percentage concentration of the annual thermal efficiency. Denoted with the small alphabetical symbol, this index is not applied to frosted climate, that is E dash. See, E dash is the frosted climate which is present in the third indexes, but this is absent over here. In this index, the calculation of the concentration of thermal efficiency during the summer as the percentage share of the total annual thermal efficiency. Thus, index clearly depicts that with the increase in the sign of latitude, the thermal efficiency concentration during the thermal will go on increasing. But what is this thermal efficiency concentration? See, basically what happens is that as we move away from the tropical to the temperate, the amount of solar insolation in general decreases. Hence, what happens is that the capacity of the plants to utilize the minimum sunlight increases, and that is called thermal efficiency. Means how much sunlight the plant can basically utilize. Now, the Thornthwaite classification scheme. What was the benefit of this Thornthwaite's classification scheme? Let's go on for this is the benefit. Thornthwaite classification scheme in combination demarcated alphabetical symbol involves nearly 125 recognized climates practically on the map of the world. Means it was able to recognize more number of climates. Second, it is more than 32 climates that can be demarcated. Thus, this justifies that the Thornthwaite's classification scheme being specific in nature. Means it can demarcate microclimates which the Köppen could not. Köppen's climatic classification was mainly a macro classification. Thornthwaite went into the micro classification. Next, this scheme, however, can be utilized to demarcate the climatic region of the smaller area as in the individual countries of India. Now, Thornthwaite classifications makes two methodological improvement over the Köppen scheme. in availing the relativity of the temperature and precipitation. Köppen used absolute, Thornthwaite used the relative temperature and precipitation in distinguishing the climate type. It is this climatic classification scheme that is best utilized for the field of the applied climatology. In the field of applied climatology, what is applied climatology? When this concept of climatology is applied in real basis, that is called applied climatology. Next, among the major fields, we have the agriculture, planning, crop standing. However, it is this climatic classification that avails the support to decipher the regional and seasonal variation of the soil moisture. This is all clear. Now, let's go for the what were the demerits of the Köppen. Now, basically, the demerits of the Köppen. The Thornthwaite's classification. I'm sorry, Köppen. Next, the Thornthwaite classification of the world climate is improved quantitatively. However, the classification seems to have ignored the role of the prevailing wind, relative humidity, air pressure, and air mass. Now, all this were also completely discarded by whom? Köppen. He also did the same mistake. The classification system has proved most satisfactory in case of North America, where the vegetation boundaries is nearly coincides with the PE value. What is the P by E value? P by E value is nothing but your potential evapotranspiration. I am not writing it in the full. But it is not satisfactory with respect to tropical and arid climate. Remember this. Though it was helpful in case of what? It was helpful in case of North America, but similarly it was not helpful where? In case of India case. Means India and other countries not that kind of a helpful. Next, the calculation of the soil moisture balance for the different natural region and vegetation zone poses a basic problem. Several combination at local and regional level increases the complexity of obscuring the clarity of classification. Next, availability of the data for all the meteorological variable over the time and space is a serious problem. That is, data was not available for everywhere. Next, despite being an improvement in the classification qualitatively, it is less used and of limited application because of its complex nature. So basically, I can simply say it was complex in nature. This point, no need to mention this full point. Simply say it was complex in nature. Next, the Thornthwaite's classification of the world climate is improved qualitatively. However, classification of climate seems to have ignored the role of relief. Again, one of the major problems. The position of the sun with reference to the incidence of the solar radiation of the earth. This is mainly an important point. What at this point is trying to say that they did not take into account the world climate. That is, most of you have heard of the apogee and perigee. Apogee means distance. This is the sun and this is the earth. This is your apogee, means the sun is at a greater distance from earth, and this is your perigee, means the sun is very nearer to earth. Now this thing also affects the climate. Now this has also not been taken by Köppen. Again, current issue of the global warming, climate change, increasing incidence of the extreme events does not find in classification the Thornthwaite's does not find its place in the Thornthwaite's classification. These are the basic demerits. We have the 7 demerits with respect to Thornthwaite's classification. And if you say that most of the demerits that were available with the Thornthwaite were also available with the Köppen. Even Köppen did not take into account the climate change. So basically they couldn't have taken into account the climate change because that climate change was not that stark over there. However, in the contemporary times, climate change is important and such things should be taken into climatic classification, which Köppens and Thornthwaites at that time did not take. This is the thing. Thank you.